Hey guys, in this video, we are going to be talking about rate of change and slope. So we're a little familiar with this already when we've learned how to decide whether or not a table is linear, but we're going to take it one step further and actually calculate what the rate of change would be if the table is in fact linear. So goal number one, calculate and interpret the rate of change, okay? So if I have a table here, remember what I said, you need to have a constant rate of change on the x's in order to be able to check the rate of change on the y's. So the first thing we want to do is find 2 points that we can compare to one another. Now, I immediately see that 8 minus 3 is 5 and 5 minus 3 is 2. So these are just going to be the 2 points that I choose. Now, it doesn't have to be these two. I'm pretty sure each of these are subtracted by 3. So you could have picked any points that you wanted to. Those are just the ones that I'm going to choose. So it's minus 3 on both sides here, which allows us to compare the change in y's. So negative 3 plus 2 would give me negative 1. And negative 1 plus 2 gives me positive 1. So this table does represent a linear function. And if I want to find the rate of change, we need to remember that it's the change in y over the change in x. So I see that the change in y is 2 and the change in x is negative 3. So the rate of change is, I'm just gonna, negative 2/3. That's my rate of change. All right, let's try the next one here. So to go from 22 to 29, I have to add 7. 29 plus 7 is also 36. So let's just go ahead and do these top two. And then let's take a look here at the y's. All right, to get from negative 4 to negative 1, I would need to add 3. But to get from negative 1 to 1, it's adding 2. So this one is not linear. So we don't have to worry about calculating the rate of change because it's not linear. Okay, now taking that idea, what we need to do with this table is complete it, so fill in the blanks, so that the function is in fact linear. So let's take a look at how the x's are changing. I see that to go from 11 to 10.5, I'd subtract 0.5. Subtract 0.5, I get 10. Subtract 0.5, I get 9.5. So to go up the table, I'm going to add a half each time. So 11 plus 0.5 is 11.5. And 11.5 plus 0.5 is 12. So I've completed the left side of the table. All right, now on the right side, we need to figure out what the change is from one of the y's to the next one. I'm going to use the positive ones because those are typically easier to deal with. To get from 7.5 to 10.75, I need to add 3.25, which means as I go down the table, I'm always adding 3.25. And if I go up the table, I'd be subtracting 3.25. So let's do that. So 10.75 plus 3.25 is going to be 14. And then let's go backwards. 7.5 minus 3.25 is going to be 4.25. So this table is now linear. All right. Next thing we're going to do is calculate and interpret slope from graphs. So you guys are pretty familiar with finding this. You know that slope of a line is the change in the y coordinates, which is the rise, for the corresponding change in the x, which is the run. So how you always put y's on top. So do you increase or decrease from the point farthest to the left to get to the other one, and then how far right do you need to go? So let's just do that. So I always start with the leftmost point. I see that to get to the other point, I need to go up, which means my slope is going to be positive. We go up 1, 2, 3, 4. And I'm going to go over 1, 2. And then all I want to do here is simplify this fraction. 4 over 2 is just 2. So my slope is 2. Same thing for this one. Start with the leftmost point. I'm going to go up 1. So that's a positive 1. And to the right, 1, 2, 3. Now 1 over 3 does not simplify. So that is my slope. Now, these last two are special types of slopes. If you notice, this one is just a flat horizontal line. And when that happens, the line is neither increasing nor decreasing. So we call this a slope of 0. That's a 0 slope. This one, on the other hand, first of all, is not a function. It's a straight vertical line. So we can't actually define the slope here because it is straight up and down and therefore not a function. So we literally just call this an undefined slope. You can abbreviate with the letters U, N, D. Now, you're not always going to be given the graph to find the slope. Sometimes you're going to have to find it from 2 points, which is what this next section of the notes is all about, okay? So you should be pretty familiar with this as well. We're going to find the change in y over the change in x. So basically, to find change in, we are going to use subtraction. It would help if I could spell. Okay, so if I want to find the change in y's, I'm going to subtract the y's. So I'm going to do 4 minus 7 on top and negative 3 minus 1 on bottom because I'm finding the change in the x. 4 minus 7 is negative 3, and negative 3 minus 1 is negative 4. And once again, I do want to simplify the fractions. The only thing I can do here is get rid of the negatives because negative over negative is a positive. So my slope of the slope of the line between those 2 points is 3 over 4. All right, let's do the same thing for B. So change in y means negative 5 minus negative 5. Be careful not to let the minus take the place of the negative. You must have both here. And then on the bottom, we have negative 2 minus 4. Now, negative 5 minus negative 5 is 0. So it doesn't matter what's on the bottom. Negative 2 minus 4 is negative 6. But 0 divided by anything is just 0. All right, next one. We have 4 minus negative 2 on the top and negative 3 minus negative 3 on the bottom. 4 minus negative 2 is 6. And then negative 3 minus negative 3 is 0. Now, you cannot divide by 0, which automatically makes this an undefined slope. If you tried to put that in your calculator, it would give you an error, and that should be a dead giveaway that your slope is undefined. So this slope would be a vertical line, straight up and down. All right, now this next one here, we have 3 minus 1 on top and negative 1 minus 4 on the bottom. 3 minus 1 is 2. Negative 1 minus 4 is negative 5. And we can't simplify this further. There's only one negative, and 2/5 does not simplify. All right, this last one down here at the bottom says find the value of r so that the line passing through negative 4, 5 and 4r has a slope of 3/4. So this is a little tricky. Now, once again, I know that it's change in y in the top of my fraction. So that would be 5 minus r on the top. And on the bottom, I have negative 4 minus 4. So negative 4 minus 4. And I want this to be equal to 3 over 4. Keep that in mind. Now, here's the thing. Negative 4 minus 4 is going to be negative 8. So I should probably move this over a bit. So on the bottom, I'm going to have negative 8. And I still have 5 minus r on top because I don't know what the r is. But I want to end up with it being 3 over 4. So that means I am going to need to figure out how do I get from negative 8 to 4. Well, the answer is divide by negative 2. So whatever I get up here, when I divide it by negative 2, I need to get 3. So let's think of that backwards. If I divide by negative 2 to get 3, that means I would have to do 3 times negative 2 to get 5 minus r. Now, 3 times negative 2 is negative 6. So I know that 5 minus r is going to have to be equal to negative 6. All right, now we just solve this like an equation. So subtract 5. We have negative r equals negative 11. And to solve that, we divide by negative 1. And I get r equals 11. So if I put an 11 here, 5 minus 11 would be negative 6. Negative 6 over negative 8 simplifies to 3/4. All right, last section here is a real-world scenario. So continental slope is the slope between the outer edge of a continental shelf. So this here, where it dives into the water, is called a continental shelf. So from that point to the ocean floor is called a continental slope. So the image that you see here represents the continental slope at Cape Hatteras. All right, it says, what is the measurement of the continental slope? So we know that the point right here is this ordered pair that they give us. It's 75, negative 65. And what that means is this point right here is 75 meters from the shore, but also 65 meters below the ocean surface. So they're saying that this right here is basically where the origin is, okay? So it is 75 meters from the shoreline, but also 65 meters below the surface of the water, okay? Now, this point here is 125, negative 2,700. So it's 125 meters from the shoreline and 2,700 meters below the surface of the water. So to find the slope here, we're going to do the exact same thing that we've done with all of the other slope problems that didn't represent a real world scenario. So I know it's change in y over change in x. So the change in y would be negative 65 minus negative 2,700. And then on the bottom, the change in x is 75 minus 125. And I'm going to break out my calculator here to make sure I don't make any mistakes. So negative 65 minus negative 2,700 is going to be 2,635. Okay. And 75 minus 125 is negative 50. So now what we're going to do here is simplify this. And this calculator is really nice because I can just put it in as a fraction and let it do all the work for me. It simplifies to negative 527 over 10, which is approximately negative, it's not approximate, it's exact, negative 52.7 meters. So the slope there is negative 52.7 meters. And that's it. That's how you find rate of change and slope.